Right, good afternoon. So I will be presenting to you today FinX ABSA, which is about explainable finance through aspect-based sentiment analysis. Right. So I'm currently a year one PhD student under NUS Digital FinTech. Being co-supervised by Prof. Eric as well as Prof. Giammarco. Just to give you a brief introduction on the motivation of this paper. Essentially, we have traditional AI, which gives us a lot of black box methods. And currently now, there's been quite a few research publications into explainable AI, which allows us to which provides tool for us to make sense of AI decisions. And these tools are increasingly important in fields like finance, where we have seen a greater AI use in finance, and we require more transparency, accountability, as well as trust in financial decision making, which is powered by AI. So this is basically a framework for us to use explainable AI in financial sentiment analysis. Essentially, what we first do is we will get list of financial aspects, and we will run aspect-based sentiment analysis via graph convolutional network. Thereafter, let me just give you an example of this. So essentially what this aspect-based sentiment analysis is able to do is to take a sentence such as this. So too many families don't know if their next paychecks will cover their expenses, and inflation is wiping out the middle class. So we're able to take an aspect of this sentence, for instance, inflation, and we are able to explain specific sentiment analysis for this particular aspect. So this aspect-based approach allows us to have a more explainable financial analysis. And what we aim to do in our paper is to collect financial text information from Twitter, as well as a host of specific financial aspects related to what people have been using in the everyday world of finance. So for instance, aspects related to inflation, economy, stock market. You can see like the full list of financial aspects in our paper. And we want to add some interpretability through statistical tests. So this is just an overview of what we aim to do. So on the left, you see our collection of data. So both our financial aspects as well as our tweets, our text corpus, which we'll be running our analysis on. And thereafter, we will run some statistical tests in order to add some interpretability. So how do we collect financial data? We collect financial data from Twitter through keyword hopping. So this is a method that we use. So what this entails is basically we'll get a first corpus of financial text through our preliminary keywords, which is NASDAQ stock market, just a very simple one. We'll filter new keywords according to their top frequency. So we'll get a host of more than 20 keywords, for instance. And then we use these new keywords to collect our second corpus of text. And we'll perform our sentiment analysis on our second corpus of text as well as our statistical tests. So we also obtain stock prices because we want to see how relevant our sentiment analysis can be. So we take from Yahoo Finance, we take from traditional energy, sustainable energy, so on and so forth. And what we do have next is a collection of financial aspects for aspect-based sentiment analysis. So as previously mentioned, is the daily words which are used in the financial world. And we draw on previous research which has derived these words from different methods which is entailed in this relevant literature. So it's by the host of methods as stipulated in the slides: matrix factorization, LDA, PCA, expert annotation as well. And then after we collate financial aspects, we can feed them through our Sentic graph convolutional network, which aims to learn contextual representations between the words through LSTM layers, and thereafter derive some latent contextual representation. Thereafter, we feed these latent contextual representations together with effective graph, and we are able to express sentiment dependencies. So after using this algorithm, what we then do is to label aspect sentiment polarity, which is basically whether or not your tweet or particular tweet is positive, negative. And then we compute the frequency of these polarities to get absolute frequency, which is positive or negative sentiment scores, and we'll refer to them as such. And basically your polarity of these tweets per day, as well as your normalized frequency, which is taking your absolute frequency over the total labels of the particular aspects every day. And we select the top 20 aspects, which are from basically your absolute frequency per day. So these are the most relevant ones. So what statistical steps do we use? We use Pearson correlation because it is commonly used in the financial world now, just as a preliminary base step for explainability. We use also Gradient causality, which will allow us to validate some of our findings, which will tell us like whether or not one particular time series is able to forecast the other. And we also use Tails U, which allows us to compare relative information, which is contained within this aspect sentiment scores through entropy values. So this is just a visualization of Pearson correlation. So we can see that from our particular aspect sentiment scores derived for the different aspects, we have two in particular, inflation and economy, which yields very, very high Pearson correlation values, right? Okay, I mean, yeah. All right, so we will just go through like just the Pearson correlation scores just roughly for absolute sentiment, and the full coverage of the full details and all the results of all the Pearson correlation done can be found in the paper. So we'll see these are for the normalized sentiment scores, which have lower correlation, but some of the correlation is still significant at around 0.4. All right, then now we'll talk about Tails U. So I just want to talk about the intuition of this. So we will have basically relative information provided by the different aspect sentiments, and then we can compare between them using this entropy values. Right, so H is basically your conditional entropy of a price given some aspect sentiment scores, and a reduction of uncertainty in price given aspect sentiment scores represented by H as well. Right, so this is the intuition, which is basically if you have a greater value of H, you have a greater uncertainty reduction and therefore greater information provided by the aspect sentiment score. Right, so this is just a distribution of different H values or Tails U's values. So the most informative you can see is inflation and cost on the left side, which is for negative sentiment scores and stock prices. Well, on the right side for stock prices and positive sentiment, you can see the most informative are inflation and bank. Yeah, so now we talk about Granger causality. So Granger causality basically allows us to validate the forecasting ability of aspect sentiment scores. Basically, it tells us whether or not one time series is able to forecast the other, or is useful for forecasting another. And the way we do this is to insert lagged aspect sentiment score in a regression equation with stock prices. So after that, we do some statistical tests, which is basically your F test. We want to see whether or not the coefficient of the lag aspect sentiment score is greater than 0. And what we will then do is to reject a null hypothesis that the aspect sentiment score is not useful for price forecast at the 0.05 level. Yeah. So through the results that we have obtained through this framework, we just want to have like some discussion on how we have derived some form of explainability. So we can see that through our aspects and in combination with Pearson correlation, aspects such as tax, price, financial, and economy has a negative Pearson correlation for negative sentiment scores, which basically means that a reduction in pessimism for these different aspects, which correspond to different economic and business conditions, will result in an increase in stock prices, or is correlated with an increase in stock prices. So there is some form of explainability which is derived because now we know what the sentiment relates to, and we can use economic theory to explain. So the next one is also like our ability to test robustness of aspect sentiment scores using Granger causality. So essentially, we have the aspects of financial and stock, which passes the Granger causality test. And beyond getting this significant Pearson correlation, which we talked about earlier, this is also indicative of forecasting power. Basically, your lagged sentiment scores corresponding to these aspects are useful for forecasting stock prices. And lastly, we show like how if you use your tails use value, you're able to derive, which is the more important sentiment features. So you can compare basically your relative degree of information provided by aspect sentiment scores through your tails use value or your uncertainty coefficient as previously talked about. So the higher the tails use value, as we said previously, the greater the reduction in uncertainty and the more information possessed by a particular aspect sentiment score. So you can see economy as well as inflation have the highest tails value. Yeah, so in conclusion, FinX ABSA, which is our paper, is a framework for explainable finance through different tools which are used, right? So one of them is our ability to mine financial aspects and text corpuses, and then feed these financial aspects through financial aspect-based sentiment analysis through our Sentic graph convolution network, as we previously said, and to run statistical tests which are complementary with each other and also complementary to this aspect-based sentiment analysis. Yeah, so we've derived some appreciable results from this framework, and yeah, that's it. Yeah, so if you would like to talk more about utilizing this framework or talking more about research related to this framework, if you have any more questions, you can connect with me on LinkedIn. And yeah, thank you.